Carboxylic acids. Carboxylic acids contain the functional group, the carboxyl group. And what that is a combination of a carbonyl and a hydroxide group. So it's got its own name, carboxyl. And because that carbon can only bond to one other carbon, it's always on an end carbon, like the aldehydes. So its functional group is carbon number 1. So you start numbering from that end. These are weak acids. So they do form an equilibrium in water. And to name them, find the longest continuous carbon chain containing the carboxyl group, and that becomes your root or your parent chain. For the suffix, you take off the E from the parent or the root, and you add oic acid, and that is your suffix. And again, of course, you have to identify any side groups and their location. And same rules apply alphabetically. So to name these two, if we look at the first diagram, here's your carboxyl group. That's carbon number 1. There's one other group attached. So this is ethanoic acid, because there's 2 carbons in that longest carbon chain. So ethanoic acid. In the next group, next diagram, here's our functional group. And the longest carbon chain is 4, and we have a side group that's a methyl group. So because the carbon that the carboxyl group is number 1, that means we have our methyl group on carbon number 3. And it's 4 carbons long, so it's butanoic acid. So 3-methyl-butanoic acid. So, drawing from a name. Identify your root. Draw out the longest carbon chain. Add the double bonded O and the OH to the end carbon, and then add any side groups appropriately. So meaning the right numbered carbon. Okay, so let's identify the drawings for these 2 names. Propanoic acid. So the root is prop, so it's 3 carbons long. So the carboxyl group is on the end carbon. Put in the rest of our hydrogens. There's our propanoic acid. Next structure, 4-methyl pentanoic acid. So we've got a side group on carbon number 4, and our root is pent, so 5 carbons long. Our 5th carbon, or our first carbon, is our carboxyl group, and then count away from there. So 1, 2, 3, 4. There's our methyl group. Put in enough bonds so each has 4, and then place your hydrogens. So there's 4-methyl pentanoic acid. Carboxylic acids are very polar, and this is because the C double bond O bond is polar, as is the CO and the OH bond. These are both polar bonds. Sorry, these are all polar bonds. So, what happens here in terms of solubility is this portion can make hydrogen bonds with water, and this portion can accept hydrogen bonds with water. So water is actually doing the hydrogen bonding there. So that should really say from water. So they're very soluble. Except again, once you start getting a very large carbon chain, the solubility decreases. So carbons 1 to 4 are miscible with water. Miscible means infinitely soluble. You can just keep adding as much as you want and they will still dissolve. Once you get to 10 carbons and up, they become insoluble. So quite soluble. Now in terms of boiling points, they are much higher than the other groups. And this is due to the fact that they have 2 sites for hydrogen bonding. With each other. So they've got London dispersion, dipole-dipole, and hydrogen bonding. So these have a higher boiling point than alcohols of the same carbon length.